All right, so this lecture will be lecture one in our study of logic. We will do a little logic. We will not do in-depth logic, but it's important that we have a basic understanding of logic and the nature of deductive logic, the nature of inductive logic, and logical fallacies. So I'm going to pull up a textbook on logic, and I will post this chapter to your course modules page for your reference in the future and for your reference with regard to prepping for the exam. But and I will point out in this lecture what you need to make note of in the actual chapter on logic that we're looking at. We'll not cover this chapter in depth. We will just cover some of the basic concepts and all. So I'm going to pull that up now. Let me see if I can find it. One moment. There it is. All right, so you should be able to see here this chapter that deals with logic. So we're going to be concerned with certain portions of section 1, what is logic, section 2, inferences and arguments, and then deductive versus inductive logic. So I'm going to slide down here, and you can make note of this as you watch the lecture and pull up the textbook. This is not the primary textbook. This is just a textbook on logic. This is one chapter out of a textbook on logic. I'm providing it for you on your course modules page without charge, obviously. So what is logic? A lot of times when people think about logic, they think of the question of, well, am I a logical person? Well, there's a difference between being what we might think of as a logical person and the formal study of logic. The study of logic is a formal discipline. It's a formal concern. And so being a formal discipline, there are certain kinds of rules that have to go along with logic. So don't just think of logic as being a logical person. Logic is a formal discipline as we're using it here in this particular material. I'm trying to get rid of that light that's reflecting. All right, so notice it says, what is logic? Logic may be defined as the science of reasoning. The science of reasoning. That's what logic is all concerned about. Logic is concerned with reason. Logic is concerned with rationality. Logic is concerned with step-by-step reasoning that is coherent, that is structured, and you will see that in one moment when we look at some examples. Logic is not just an empirical science or experimental science. Logic is a rational discipline, and there are two types of logic. There is deductive logic, D-E-D-U-C-T-I-V-E, deductive logic, and then there is inductive logic, I-N-D-U-C-T-I-V-E, inductive logic. And we will give definitions to those differing approaches to logic in one moment. So for this purpose, the thing that you need to take away is that logic is best defined as the science of reasoning in a coherent, deliberate, intentional, and concise manner. So with that in mind, we move on down here. In logic, there are what we might call inferences and arguments. So what is an inference? We say, well, you can infer this or you can infer that. What is an inference? Notice on the top line here under inferences and arguments, reasoning is a special mental activity called inferring, what can also be called inferences or performing inferences. So the following is a useful and simple definition of the word infer. To infer is to draw conclusions from premises. All right, so what do we mean by premises? Let me give you an example of premises. Premise one, and we'll see this later on. Premise one, all men are mortal. Premise one, all men are mortal. That means all men die. Premise two, Socrates is a man. Premise one, all men are mortal. Premise two says Socrates is a man. So what's the conclusion of those two premises? If we conclude, as the premise one says, that all men are mortal, and if we conclude that Socrates is a man, then based upon those two premises, it is required that we conclude that therefore Socrates is mortal. So if all men are mortal, and if Socrates is a man, then it is required that we conclude Socrates of necessity must be mortal. All right? All right, so that's an example of what are premises. All right, so to infer something is to draw conclusions from premises. If we believe all men are mortal, if we believe that Socrates is a man, then we can infer that Socrates, therefore, is mortal, all right, that he's going to die. All right, so here we go. With regard to more specifics with regard to inferences, notice on the page in front of you examples of inferences. You see smoke, and you infer that there is a fire. All right, so let's just put that in terms of a logical argument. Premise one, where there is smoke, there is fire. Premise one, where there is smoke, there is fire. Premise two, there is smoke in this room. Conclusion, therefore, there must be fire in this room. All right, so you can infer that there is a fire in the room if you accept premise one and premise two. All right, look at the second example. You count 19 persons in a group that originally had 20 people in it. You infer that someone is missing. So you say, premise one, this room had 20 people in it. Premise two, this room currently has 19 people in it. Conclusion, therefore, you can infer that one person is missing. They've left the room. All right, so that's an example of inferring. If premise one is true, if we accept premise one as true, if we accept premise two as true, then we must conclude what? All right, so note carefully the difference between infer and imply, which are sometimes confused. We infer the fire on the basis of the smoke, but we do not imply the fire. On the other hand, the smoke implies the fire, but it does not infer the fire. The word infer and imply are not synonyms. They're not equivalents. So to infer is not to imply. All right, so that's inference. Now then, let's move down a little further. All right, what is an argument? That's the next thing that you need to take away from this. An argument is a collection of statements, one of which is designated as the conclusion, and the remainder of which are designated as premises. Now, I just gave you an example of that. I said premise one, yada, yada, yada. Premise two, yada, yada, yada. Conclusion, therefore, yada, yada, yada. All right, so premise one would be all men are mortal. Premise two, Socrates is a man. Conclusion, therefore, Socrates is mortal. That the totality of those premises and that conclusion, those things constitute an argument. I'm making an argument. I tell students to do this. When you see those kinds of things, you read it as follows. if I conclude that all men are mortal, and they are, all of us die, but if I conclude that, or if I accept that all men are mortal, if I accept that all men are mortal, and if I accept that Socrates is a man, therefore I must accept that Socrates is a mortal. All right, he is a mortal, he is going to die. All right, now, so an argument is a collection of statements, one of which is designated as the conclusion. And we're dealing with the most basic of syllogisms here. These things are what are called syllogisms: premise one, premise two, conclusion. Generally, that's the structure of the basic syllogism that we're going to be looking at, and that you'll see on the test or the examination in a week or so. Now then, note under this definition of argument, note that this is not a definition of a good argument. Also note that in the context of ordinary discourse, an argument has an additional trait described as follows. Usually the premises of an argument are intended to support the conclusion of the argument. All right, so the premises support the conclusion of the argument. What is the conclusion of the argument regarding Socrates? The conclusion of the argument regarding Socrates is Socrates is mortal. All right, what are we basing that upon? We're basing that upon premise one, all men are mortal. And premise two, Socrates is a man. If all men are mortal, and if Socrates is a man, therefore we must conclude that Socrates is a mortal. All right, so that's an example of an argument. All right, and the purpose of the premises support the argument. All right, now then, the premises are this little section here in the block. A statement is a declarative sentence, which is to say that a sentence is capable of being true or false. All right, so in a moment, when we look at some samples, or later on in maybe a subsequent lecture, when we look at some examples, the premise may actually be false in real life. With regard to Socrates, those premises are true in real life. It is true that all men are mortal. It is true that Socrates is a man. All right, those premises are true. But what if the premises are false? What if the premises say this? All things that can fly have been to the moon. Premise one. All things that can fly have been to the moon. That is not true in real life. All things that fly have not been to the moon. But the premise says, premise one, all things that can fly have been to the moon. It's not factually true, but we're called upon to accept that premise. Someone writes in front of us, premise one, if we assume all things that can fly, or if we accept that all things that can fly have been to the moon, premise one. Premise two, hippos can fly. Premise two, hippos can fly. That's not true in actuality. That's not true factually. Hippos can't fly, really. But the premise is asking that we accept that. So if I accept premise two, that hippos can fly, then therefore what must I conclude? All right, so premise one said, all things that can fly have been to the moon. Premise two says hippos can fly. Neither one of those is true. But if I accept them as true, what must I conclude? Well, I must conclude that hippos have been to the moon. All right, that entire argument is not factually true in the sense of all things that can fly have not been to the moon. That's just not true. It's not true in the sense that hippos cannot fly. That's not true. But if I accept them as true, if I treat them as true, if I regard them as true, then I must conclude, therefore, that hippos have been to the moon. All things that can fly have been to the moon. Hippos can fly. Therefore, of necessity, hippos have been to the moon. All right. So even if the premises are not factually true, we still look at the argument to see if it is a valid argument. That's a valid argument. All right. So a statement is a declarative sentence. So a premise is a statement. A premise is a statement. All things that can fly have been to the moon. That's a declarative statement. I'm just declaring something. All right. Premise 2, hippos can fly. That's a declarative statement. I'm just declaring something, just saying something. All right. But those statements can be either true or false. Those statements are false. The other statements that I cited, Socrates, all men are mortal. That's true. Socrates is a man. That's true. So those premises are actually factually true. All right. But the hippos, fact, a declarative statement, those are not true. All right. So they're declarative sentences. Premises are declarative sentences that can be either true or false. All right. Now then, let me look at this next section here. The following are examples of statements. It is raining. That's a statement. It is raining. It's a declarative statement. I am hungry. That's a declarative statement. I'm simply declaring that I'm hungry. 2 + 2 = 4. That's a statement. I'm simply declaring that 2 + 2 = 4. God exists. That's a statement. God exists. I'm simply declaring something. On the other hand, the following are examples of sentences that are not statements. Are you hungry? That's not a statement. That's an interrogation. That's a question. Shut the door. That's a command. All right. Replace the next one with your favorite expletive. All right. You have an exclamation point after that. That's an expletive. That's a command. All right. Those are not statements. All right. A statement is a simple declarative sentence. It is raining. I am hungry. 2 + 2 = 4. All men are mortal. Socrates is a man. Hippos have been to the moon. All right. Those are simple statements. All right. Observe that whereas a statement is capable of being true or false, a question or a command is not capable of being true or false. All right. So the point of all that is this, that premises are declarative statements, and as declarative statements, they can either be true or false. All right. So now then, let's look at these other examples we just talked about. There is smoke, therefore there is fire. We can make that a little more sophisticated. Where there is smoke, premise 1, where there is smoke, there is fire. 2, premise 2, there is smoke in this room. Conclusion, therefore there is fire in this room. All right. All right. So I think you get the gist of that. Premise 1, there were 20 persons originally in this room. Premise 2, there are 19 persons currently in this room. Conclusion, therefore someone is missing, someone is left. All right, so those are examples of basic, simple syllogisms. So what have we learned from that? We've learned that that premises are simple declarative statements. We've learned that as declarative statements, premises can be true or false. We've learned that even a statement, even premises that are not true in actuality can still be a valid argument. Remember the hippos. It's not true in actuality, but it's still a valid argument. If I accept that all things that can fly have been to the moon, and if I accept that hippopotamuses can fly, therefore I must conclude that hippopotamuses have been to the moon. All right. So factually, it's incorrect. It's not true. But logically, it's a valid argument. Right. If I accept 1, I accept 2, then I must accept the conclusion. All right. All right. So that having been said, now then let's look at, I'm going to move on down here. We talked about also the fact that the premises are intended to support the conclusion. So make note of that. The premises are intended to support the conclusion. All right. Now then, 2 types of logic, deductive logic and inductive logic. All right. Deductive logic. Deductive logic versus inductive logic. What is the difference between these things? All right. So let us go back to the 2 arguments from the previous section. There is smoke, there is fire, there are 20 people, there's currently 19. All right, so let me come down here to the definition of if I can find it. I think there's a simple definition of deductive logic that I want you to make note of. Let's see. Okay, so if you look at these two arguments, there is smoke, therefore there is fire. The line under that says there's an important difference between these two inferences, which corresponds to a division of logic in two branches. One of these is an example of deductive logic. The other is an example of inductive logic. All right. So, all right. On the one hand, we know that the existence of smoke does not guarantee or ensure the existence of fire. It only makes the existence of fire likely or probable. All right. Thus, although inferring fire on the basis of smoke is reasonable, it is fallible. It is possible for there to be smoke without fire. We may be wrong in asserting that there is fire. This is an example of inductive logic. Now, let me put that in a little bit more of a simplified fashion. Look at the argument. There is smoke, therefore there must be fire. Well, that's an example of an inductive argument. It's moving from a general to a specific, first of all. It's moving from a general to a specific. And it addresses probability. Where there is smoke, we can read it like this. Where there is smoke, there is probably fire. Right? Therefore, where there is smoke, there's probably fire. There is smoke, therefore there is probably fire. Inductive arguments such as A1 there are based upon probability. Inductive arguments are based upon probability. You will see that on the exam. Inductive arguments are based upon probability. There may be other causes of fire. Other causes of smoke. All right. There may not be fire, but we can safely assume that where there is smoke, there is probably a fire. Inductive arguments are based upon probability, but deductive arguments are based upon certainty. Deductive arguments are based upon certainty. There were 20 people originally in this room. There are 19 persons currently in this room. Therefore, someone is missing. There's no probability about that. It's not probable. It's not, you can't say, therefore, probably there is someone missing. No, there is absolutely, certainly, indisputably, indubitably someone missing. That's an example of a deductive argument. Deductive arguments are based upon certainty. You'll see that on the exam. Inductive arguments are based upon probability. Deductive arguments are based upon certainty. All right. Let me see. I just want you to get the gist of this. All right. Notice at the bottom of that page, it says consider A2 above. In this argument, if the premises are in fact true and we accept them as true, then the conclusion is certainly true. Or to state things in the subjunctive mood, if the premises were true, then the conclusion would certainly be true. If there were originally 20 people in this room, and if there are now 19 people in this room, it is therefore certain that there's one person missing. So deductive arguments are based upon absolute certainty. This is deductive logic, all right? Now then, let me see. What else do I want you to take away from this? Let me see. All right, so I think I want to move to the next section that deals with validity and soundness in an argument. I'm going to move to that in the next, but I do want to go over this section right here that I pulled up. Preliminary definitions. In the present section, we examine some of the basic ideas of logic. As we saw in the previous section, there's a distinction between logic and form and content. There's likewise a distinction between arguments that are good in form and good in content. All right, so let me see. Look at these arguments. These arguments here on the page are demonstrating the difference between goodness as it pertains to form of an argument and goodness as it pertains to the content of an argument. Look at the first one, A1, all right? All cats are dogs. All dogs are reptiles. Therefore, all cats are reptiles. All right, if we look at that argument, the first thing you're going to say when you look at that is, that's absurd on its face. On its face, at the most superficial level, you read that and you say, that's not true. All cats are not dogs. All dogs are not reptiles, and cats certainly are not reptiles. All right? All right? Then look at the second argument, A2. All cats are vertebrates. All mammals are vertebrates. Therefore, all cats are mammals. Now you're going to look at that one and you're going to say, well, that makes sense. All cats actually are vertebrates. All mammals are vertebrates. Therefore, all cats are mammals. Now, let's look at this. Neither of these arguments is good, but they are bad for different reasons. First, look at their content. All the statements in A1 are false. All the statements in A2 are true. That's obvious. Cats are not dogs. Dogs are not reptiles. All cats are not reptiles, right? And number one, that's obvious. All right. A2, all the statements are true. All cats really are vertebrates. All mammals really are vertebrates. All cats are mammals. That's true. Since the premises of A1 are not all true, this is not a good argument as far as content goes. So the content of argument A1 is not good. All right? But the content of A2 is good. All right? The content of A1 is just not good because those things are not actually true in real life. Cats are not dogs. Dogs are not reptiles. Cats are not reptiles. So the content of that argument is not good. It's just wrong. A2, cats are vertebrates, mammals are vertebrates, cats are mammals. The content there is good. That's good. That's actually true, all right? So, once again, read that last sentence. Since the premises of A1 are not all true, this is not a good argument as concerns content. A2 is a good argument as far as content goes, all right? So A1 is not good, A2 is good, all right? Now consider the form of the argument. Now then, we're looking at just the form of the argument, even if the content is not good. What about the form? All right. Now consider their forms. This will be explained more fully in a later section. The question is, under form, when you're looking at the form of the argument, the question is, do the premises actually support the conclusion, even though the premises in content might be untrue? Does the conclusion of necessity follow from the premises? All right. All right. So let's look at this. As in the case of A1, the premises do in fact support the conclusion. All cats are dogs. All dogs are reptiles. Therefore, all cats are reptiles. Well, in content, that's a bad argument because the content is just out and out wrong, right? It's out and out wrong. It's incorrect. That's not true. But if I say on the exam, what about the form of this argument? Well, the form of that argument is coherent. It's a good argument. All cats are dogs. If I accept that all cats are dogs, And if I accept that all dogs are reptiles, then I of necessity must accept that all cats are reptiles. So that's an example of the content of the argument being bad, but the form of the argument is good. The premises lead to the conclusion. So don't just read the argument and say, well, that's not true in real life, so therefore it's a bad argument. No, it still may not be true in real life, but it still could be a good argument in form. It could be bad in content, but good in form. Now then, let's look at the second argument. The second argument is true in content. All cats are vertebrates, all mammals are vertebrates, therefore all cats are mammals. Well, all right, that's good in content, but is it good in form? By that I mean, is the conclusion required on the basis of the premises? All right, let's look and see. In the case 2, the premises are all true, and so is the conclusion, but nevertheless, the truth of the conclusion is not supported by the premises. In A2, the conclusion does not follow from the premises. To see that the conclusion does not follow from the premises, we need to merely substitute the term reptiles for mammals. Then the premises are both true, but the conclusion is false. All right, so to be quite honest, A2 is not a sound argument, a good argument, I should say, as far as form is concerned. It's a good argument as far as content is concerned. All of those things are true in reality, but form, it is not true. All cats are vertebrates. All mammals are vertebrates. Therefore, all cats are mammals. That's the conclusion is not required based upon those two premises. All right. So let me see. In examining an argument, there are basically two questions that we should ask. First of all, are all of the premises true? All right. And then number 2, does the conclusion follow from the premises? All right. So I'm going to stop right there because I know this can be overwhelming, but and a little confusing. But I want you to understand the primary emphases we've made in this lecture today about what is logic, what is a premise, what is a conclusion, what's the role of the premise, what are the role of the premises in relationship to the conclusion, what constitutes an inductive argument, what is a deductive argument, which argument is based upon certainty, which argument is based upon probability, and then the difference between assessing whether an argument is good in content versus good in form. So with that, I'm going to stop right there. And then in the next lecture, we will talk about 3 things. We will talk about valid arguments. We will talk about sound arguments. And valid arguments, sound arguments, and factually correct arguments. Factually correct arguments, valid arguments, and sound arguments. So that's where we will pick up in the next lecture. Have a great day.